The bug is already in your computer. Not metaphorically, literally. A flaw, a crack, a tiny mistake made by a human at 2 a.m. 3 years ago. It's sitting inside software you trust with your money, your work, your memories. And right now, two very different worlds are reacting to it. In one world, a company opens a ticket, schedules a meeting, assigns a priority, legal checks it. Marketing worries? A fix is planned for next quarter. In the other world, someone notices the bug while drinking coffee, posts a screenshot. Another stranger replies from a different time zone. By the time you finish lunch, the fix exists. No permission, no invoice, no roadmap slide, just a patch. Public, visible, a little messy, and somehow, faster. This is the uncomfortable truth. Some of the most critical software on Earth gets safer, not because people are paid to fix it, but because they aren't. And once you see why, it becomes hard to unsee. For most of computing history, software was a product. You bought it in a box, or licensed it with a contract thick enough to stop a bullet. The code inside was secret, locked away like a recipe. If something broke, you filed a support ticket and waited. The logic was simple. If you paid for the software, surely it would be better maintained. Open source flipped that logic on its head. Instead of hiding the code, it put everything on the table. Every line, every mistake, every bad decision preserved in plain text. Anyone could look, anyone could copy, anyone could criticize, which at the time sounded like a security nightmare. Why would you show attackers exactly how your system works? That fear made sense, until reality intervened, because the internet quietly decided to run on open source anyway. The web server that delivers pages, the encryption that protects passwords, the operating systems inside phones, servers, and cloud infrastructure. Linux, OpenSSL, Apache, Git, software written by volunteers, foundations, and board engineers, scratching personal itches. And here's the strange part. As these systems scaled to billions of users, something unexpected happened. Bugs didn't slow them down. They surfaced faster. When a closed system fails, only employees are allowed to look. That might be a few dozen engineers, maybe a few hundred, all with the same incentives, the same deadlines, the same blind spots. Open source doesn't work like that. A bug report can come from a student in Brazil, a sysadmin in Germany, a security researcher in Vietnam who just noticed something feels off. These people don't share a manager, or a roadmap, or even a time zone. They share curiosity. And that changes the math. Instead of one team protecting a code base, you get thousands of eyes drifting across it at random times, for random reasons. Someone reading for fun, someone trying to break it, someone depending on it so deeply that failure isn't an option. That doesn't mean open source is magically safe. It means failure is louder. When something breaks, there's no PR department to soften the language, no quiet internal memo. The bug is public. The discussion is public. The fix is public. The mistakes are archived forever, which sounds terrifying. Unless your goal is to fix bugs quickly, because speed, it turns out, has very little to do with money, and a lot to do with friction. Imagine a bug is discovered, not a dramatic one. No flashing screens, just a quiet flaw that sometimes crashes a program, or leaks a little memory, or opens a door that shouldn't be open. In a paid software company, the clock does not start ticking when the bug is found. It starts ticking when the bug is approved. First, someone has to reproduce it, then document it, then decide if it's real, then decide if it matters, then decide if it's worth fixing now or later. Each step adds safety. Each step adds delay. No one is lazy. They're cautious. Because touching production code can break other things. Because a rushed patch can cause lawsuits. Because fixing a bug isn't just a technical act, it's a business decision. And business decisions move slowly on purpose. Now contrast that with open source. A bug appears. Someone posts an issue. Another person confirms it. A third person proposes a fix. There is no meeting to schedule because there is no meeting. The discussion happens in public, in text, in a place designed for interruption. Here's the important part. The person who finds the bug is often the person most motivated to fix it. They're not waiting for permission. They're blocked right now. Their server is down. Their app won't compile. Their security audit just failed. Fixing the bug helps them immediately, so they do. This collapses a lot of time. In closed software, discovery and repair are separated by hierarchy. In open source, they're often the same person, or at least the same conversation. And then, something almost unfair happens. While a company's engineers sleep, open source doesn't. A fix proposed in one time zone gets reviewed in another, improved in a third, tested in a fourth. The sun never sets on the bug. By the time a corporate team logs in, the open source patch has already been debated, rewritten, and stress tested by people who had nothing to gain except satisfaction and maybe a username and a changelog. There's irony here. Paid software has more resources, more structure, more full-time experts. Open source has more chaos, more amateurs, more disagreement. Yet when a critical bug appears, chaos often wins, because chaos moves in parallel. And parallel work? When it's visible and allowed, beats perfectly organized waiting. The bug isn't just annoying anymore, it's dangerous. A vulnerability that lets attackers peek at memory, a flaw that bypasses authentication, a mistake so small it looks harmless, until someone weaponizes it. This is where the myth gets tested, because if open source really is this chaotic free-for-all, this is where it should fail spectacularly, and sometimes, it does. History remembers the embarrassments, bugs that sat unnoticed for years, libraries everyone assumed someone else was maintaining, code so widely used that responsibility diffused into nothing. But that's not the whole story, and it's not even the common one. What usually happens next is faster, stranger, almost awkward to watch. The bug goes public, not leaked, not exposed by accident, posted deliberately, with a write-up explaining exactly what's wrong. Anyone can read it, including attackers, which sounds insane until you see what happens next. The pressure spikes instantly. Now it's not one company deciding priorities. It's the entire internet watching. Security researchers start racing, not to exploit the bug, but to understand it better than everyone else. Maintainers feel the weight of reputation. Users feel the risk personally. And fixes arrive quickly because silence becomes more dangerous than action. In paid software, disclosure is often delayed to buy time. In open source, disclosure creates time by multiplying effort. More eyes don't just spot bugs faster. They argue about them faster. They disagree loudly. They test assumptions in public. Bad fixes get shredded. Good fixes get copied. The uncomfortable math reveals itself here. 10 engineers working sequentially will always lose to 1,000 strangers working in parallel, if the system lets them. Open source does. No gatekeeper decides who's qualified to help. The only filter is whether your idea survives scrutiny. Code doesn't care where you work. A patch from a nobody is just as valid as one from a famous maintainer, as long as it works. This is the turning point, because speed doesn't come from altruism. It comes from alignment. Everyone involved benefits immediately from a fix. Their servers, their products, their reputations, their curiosity, their pride. Paid software relies on incentives set by management. Open source relies on incentives set by reality. And reality is a brutally effective project manager. That's why, when things really break, the supposedly fragile system often responds first. Not because it's better designed, but because it's harder to slow down. If open source fixes bugs faster, the obvious conclusion feels tempting. Open beats closed. Free beats paid. Transparency beats secrecy. But that's not quite true. Open source doesn't win because it's virtuous. It wins because it removes friction at the exact moment speed matters most. No approvals, no internal politics, no carefully worded silence. When something breaks, the system allows anyone who cares enough to act. And that's also the risk. Because the same openness that accelerates fixes also assumes someone is watching, that someone cares, that enough people depend on the software to notice when it quietly rots. Most open source projects aren't Linux or OpenSSL. They're small, maintained by one exhausted person, held together by goodwill and late nights. When those projects become invisible dependencies inside billion-dollar products, the math flips. Now the world relies on code that no one is paid to protect. Paid software has the opposite problem. Plenty of resources, plenty of structure, and just enough friction to slow down response when speed matters most. Bugs don't die there. They age. They wait for a sprint, a quarter, a risk assessment. Neither system is safe by default. What matters is how quickly truth can surface, and how hard it is to ignore. Open source makes ignoring problems socially expensive. Closed software makes fixing them organizationally expensive. Pick your poison, which leads to the uncomfortable question most companies don't like to ask. If the software you trust is safest when strangers can see its mistakes, why do we still believe secrecy equals control? And when the next critical bug appears in code running the world, who do you actually want fixing it first? Done watching. If you like this video, hit subscribe for more cool stuff.